Hi, I'm Kylie. This is Makiel, Dana, and Matt. We're going to be presenting the Fall Detector today, which is a fall detection alert system which uses accelerometers and image processing. So this device was created to address a problem facing a lot of members of the population. The risk of the risk of injuries due to fall can strip people of their independence. And in order to address that, we wanted to create a device that would allow people to keep their independence and keep their family members informed and safe. At peace. So a quick overview of our project. We are looking at combining different existing fall detection methods in an effort to improve it. So we'll be using accelerometers and image processing. The camera will be embedded into the device, so the user will actually wear the camera. And then from that, the detection data will be used to determine if a fall has occurred, and then the individual will have a feedback system, and then the alert will be sent to an emergency contact if a serious fall has been detected. So Dana's going to start us off with talking about the accelerometer.
I'll also talk about the general PCB. So you can't unfortunately see it right there now. Sorry. So you can see that one of the LEDs is lit up right now, but this is the general how it looks like inside. So one of the main components is the accelerometer. It's an ADX345 that could directly interface with the Raspberry Pi. So the structure itself contains, that is suspended by polysilicon springs, and it can deflect easily in the X, Y, and Z axis. So what happens that the deflection causes a change in the capacitance between the fixed plates and the polysilicon springs. And what happens is that if there is movement, such as acceleration, it will cause a change in the output voltage. So the purpose of this accelerometer is to detect sudden movements, which is the user moving. So I have also soldered in 3 LEDs to determine which state you are currently in. So right now, you can see that it's in green. The green indicates that it is actively checking if how the person is moving. If there's a fall detected, then it will go into the blue state. So if a fall has been determined, then it will go into the software subroutine and trigger the buzzer. The user is able to use the button to see if they are well or not, but if they do not press it, then it will go into the red state, which will then send a text message, which is a pseudo way to indicate that emergency services have been contacted. This is my very proud diagram that I made in Google Docs, so I hope you appreciate it, but that's the general layout. So now I'm going to move on to Matt talking about the image processing.
So the image processing. So first off, like they were saying, the accelerometer goes, and we found that the accelerometer was a very effective way to determine if someone is laying down or falling, but you don't really know which one. So we figured that the image processing could kind of be a check on the accelerometer. So what happens is when you go to fall, you go below a certain level in the accelerometer. So we set it as 3 meters per second squared. Once you get below that level, we then check the video that has been recording the whole time locally on device. We compute the edge strengths and edge orientations using image processing techniques. We then take these values and bin them to reduce the computation required. And then we calculate the dissimilarity values between the last 30 frames. And then we look at each dissimilarity value, comparing each individual frame. And if we find a difference that's large enough, we set this threshold through testing, a lot of testing. It then says you have fallen and triggers the buzzer for the user. So, and then it sends a text message, which Malkiel will talk about.
Yep, so detecting the fall is one thing. We also wanted to alert a person that's related to the user that the person has fallen and they need help. So to approach that challenge, we first wanted to do a phone call, but that wasn't really possible. So then we decided, why don't we do a text message? And I was able to find an API called TextBuilt. And the API, you send a curl command through the terminal, and the API will automatically send a text message to the phone number you choose. And that's possible. So if a person's hiking, it will still be possible because the Raspberry Pi will be connected to the hotspot of your phone. And that's how it will be connected to the internet, and it'll be able to send out curl commands through that. And going over the system, we have everything combined, but we needed a way to protect it. So through multiple iterations, we designed a 3D case that would allow us to safely and intuitively protect the casing inside, but also have good functionality for the camera and the button. So this is the inside. This will be the Raspberry Pi. There's a port in here for the USB-C, and the slot in there for the camera, and the LEDs will be seen through here. So yep, we went through multiple iterations, and this was the final design. And as you can see, it fit into the fanny pack.
And just to discuss some of the risks that we faced with building this project, one of the main ones was privacy concerns because there is constantly image and video data coming into the device. All of the processing is done on board, so there's not a risk of losing data that way. Additionally, the video data isn't stored for a lengthy period of time, so the user has a low risk of their data getting out. The risk of false positives being that somebody wouldn't fall, but the device would detect that. In order to mitigate the risk of constantly sending emergency text messages saying you need help, we included the user feedback method that uses the button where the user can say, "I'm fine, don't text my relative." And then the impact of the fall breaking the device. Makiel just mentioned the 3D printed case, and that was implemented to prevent the risk of destroying our device in the case of a fall. So we're going to turn it over to Matt to kind of demonstrate how the device works.
Yes, so I don't know if I'll be able to use this while I'm doing it. Actually, I don't think I'll be able to use this. So first, I'm just going to start off by just walking around a little bit. And the first test we did was laying down. So we want to see if I go down on the ground. So if I go down and kind of lay down on the ground, it takes a few seconds. So right now what's happening is it just sensed, oh no, he's gone below the limit. Because we've been sitting up here for a little while, it's going to take a second to do image processing. Unfortunately, because it takes compressed video, it has to go through the whole video and then find the last couple frames. And so now it's saying, okay, you're still in a detecting state. So what happens now is we kind of stay on the ground, and the device is saying, okay, if you stay below that limit, you're still laying down, and we haven't detected it, so we're fine. So I get back up. And so now you can walk around like you're going on a hike, you're going on a walk, you're walking around your house, and the device is perfectly fine. And as you've seen the whole time through the demonstration, it stayed green. So now, now I get to fall on the ground. So now you go and you lay on the ground, and it takes a few seconds because it's doing the image processing. And it's not beeping, but let me reset it and try again. So that was one of the issues we've run into, but
I guess I just flew for that well.
and it does take a second to boot up. But also another thing is when we're testing it, a lot of times with a lot of people in front, it doesn't get a lot of edges. So let's see. Let's try it one more time, and hopefully you fall down. Give it a couple seconds, and you press the button because I'm okay. So now let's do it one more time. So we stand up. We're walking around. So right now it's then started a whole new recording, which are all saved numerically in your Raspberry Pi, which you can save, delete, send to your friends, anything you want to do. So, okay, so we give it a second. Oh, yeah. Doesn't detect phone calls. Yeah. So it didn't send me a text the last time because I pressed the button. No. Okay, so we're walking. Actually, we'll give it 1 second because. So normally you wouldn't fall over and over again, so that's. Okay, so you go, you walk, and you fall. So give it a couple seconds, do image processing.
I should go off on the phone. That's not okay.
And now red, so we alert a family member, and it takes a couple seconds, and then you have your text. So.
I mean, it doesn't say anything, but like, because you're,
It says, help, I fell.
Oh, I see that. Great. Oh, wait.
So yeah, and that is our fall detection device. Any questions?
Yeah, what kind of software did you guys use to display your model?
PowerPoint.
Really? Okay.
Yeah.
Very nice.
I just designed, so I put in the 3D model that I designed on online, and then I just put it in and changed the shapes that I wanted to have, and I just put it in PowerPoint. Yeah.
That's very nice.
Thanks.
Yeah, that's
Yeah.
Is there any way to see the like a live video feed of the camera?
Yeah.
A live video? So that was one of the things we were thinking about, because the problem is the Raspberry Pi captures, and it only captures in compressed video. So you have to do some really tricky, like you have to do a circular buffer, and we found that to do image processing after creating like a circular buffer was a lot more tricky for what it was worth. So we just decided to go with recording and then cutting it to the last bit. But that could be something, if we had like a little more time, we could probably fit in potentially. But yeah. And maybe a better camera, more processing power. You know, it's tough when you have such a small package. Any other questions?
Thank you.
Great, guys.